Hello everyone. In today's episode, I'll be showing you how I created the interaction between the car and the truck. To start, the truck I made is this one. Under the hood, this is as simple as a bunch of polygons sitting next to each other. So, in order to figure out if the car is on the track, we need to check if the car body is colliding with at least one polygon. Before moving forward, let's see how we can detect collisions between two polygons. To do so, we'll be using the separating axis theorem, or SAT for short. Let's say that we have two squares. Now, let's add a wall that is parallel to one square. Imagine we have a light source. If we turn that light on, the two squares will be projected to the wall. Their projections will be the shadow that we will have on the wall. Notice that there is a gap between the shadows. We can say here that the two squares are not colliding as the shadows are not overlapping. Let's see another example. Here, we can obviously see that the two squares are colliding, but let's apply the same method we used before. For the first projection, there is no gap between the shadows. We have to try to project the squares on another wall that is parallel to another edge. Same here. We don't have any gap between shadows, so let's try projecting the squares on another wall. The result is the same. Let's try another wall. Again, we don't have any gaps. Now we can say that the two polygons are colliding given that whatever axis we use to project them, we don't have any gap. On the other hand, if at least one projection results in a gap between the two shadows, we can say that the polygons aren't intersecting, therefore there is no need to check the other projections at all. But how can we calculate the position of the shadow? Let's go back to our two non-colliding squares. First, let's project the red square on the axis. To do so, we can consider the axis and each edge of that square as a vector. Then we simply calculate the dot product of two vectors. Next thing, we get the minimum and the maximum values of that projection. I call these points respectively A and B. Then, we repeat the same thing for the green square and define the two boundaries as C and D. Last thing to do is to check that C minus B is positive value. If so, there is no intersection between the two polygons. Now let's have a look at the code. So this is the function to project a polygon on an axis. We calculate the dot product and we assign its value to min if it is lower and to max if the dot product is greater than max. Then we simply return both max and min values. For collision detection, we take the two polygons and we iterate over all of their edges. Each time, we have to find the axis or the wall that we will project the polygons to. This axis will be perpendicular to the current edge. Then we project the two polygons on that axis, and we calculate the interval distance, and if it is positive, then we return false. Otherwise, we return true after iterating over all edges. Now we understand how to detect collisions between two polygons. To go back to our game, this is the code I wrote at first. I'm considering the car on the track only if its front part is on the track. The car is considered outside the track if it is not colliding with any of the polygons composing that track. For the progress made on the track, we will need to get the index of the last polygon the car is colliding with, then we divide that value by the length of the polygons. I thought that it would be an overkill to check every single part of the track each time. As an optimization, I saved the index of the last polygon the car is colliding with, then I just iterate over 6 surrounding polygons, and I keep repeating that to check the car's progress all along the way. This is the code I had after this optimization, a small change that saved me a lot of useless calculations. This way, I was able to have a different car state based on the progress that made me able to update the car color. If the car is on the track, I will display it with a blue color. If it goes outside the track, it will be displayed with a gray color. And when it is on the finish line, it will be rendered with a yellowish color. This is it for today's video. Next time I'll be showing you how I created the car's sensors. Thank you for watching and see you next time.